describes himself as someone who prefers neural networks, code, and algorithms as tools. So he fits in just perfectly. He is a Google resident for arts and culture, and most recently, in an article last week, I believe, he has been described as about as high as an authority as you can get in the field of code art. So there you go. We're really happy to have him. And without further ado, I'll hand over to Mario.
Thank you very much. Thank you. Yeah, thank you very much for having me here, and especially for sorting out kind of all my travel stuff, because like this weekend I'm on a travel marathon, so it seems like this making of interesting images pays off. And yeah, I'm an artist and interested in systems, and in particular in systems that are somehow able to make interesting images. And of course, this brings me then to the questions: what makes images interesting in the first place, and how can I make systems that in some sense don't need me anymore at some point? And I kind of have been doing this for a long time, using generative art and algorithmic art, but since about 3-4 years, when it finally became possible, I'm pretty much exclusively using neural networks and deep learning techniques to explore this space. And yeah, this talk is called Instruments of Creation, because I will talk about my process and the tools that I'm using. As you probably know, since about 80 years we are living in Walter Benjamin's art of mechanical reproduction. But I believe that this is kind of like we are ending this age and entering a new one, which is the age of artificial production, because machines are becoming capable of not only reproducing images, but in some way making images by themselves, where it becomes unclear. Questions come up: who is the author? Is it art? What's going on? So these are some examples of images that were generated. Well, that's the question. I would say they were generated by me, but in the end they came like this out of the various systems I made. So there was no Photoshop editing involved. So imagine you had seen like lots of images now that I have been creating with my machines, or I try and build these systems that make images. And the point is that right now there's a bit of a false narrative going on. I mean, we saw this horrible piece just before by this French collective, and where the story goes that the machine did this all by itself. And of course, it's not true. I mean, this is still kind of, these tools that we're using are still controlled by humans, by artists, and they make decisions which models to use, what architectures, what training sets, which images to pick in the end. So that's why I see all these neural networks, GANs, etc., as tools or instruments. And the thing is, tools have in a way shaped have been with us as humans, and as human civilization from when we called it a civilization. In a way, civilization grows with the tools that we invent or are coming up with. So starting from a rock axe, which augmented our force or enabled us to crack things that are harder than our hands are able to. The printing press, which enabled us to disperse information in much wider range than by word of mouth. This century, computers enabled us to calculate faster or more precise than we are able. And now we have these new tools, which in some way, well, as I see it, are maybe able to augment our imagination. Because in some sense, I think human imagination, we sometimes overestimate our capability to imagine things. We can always just build on, stand on the shoulders of giants and build on ideas that we have encountered before. We are very good in making new combinations, interpolating, extrapolating, transferring certain concepts, but we cannot really create something from scratch. And now we have these machines that are able to bring in information, data from the outside and produce something that is in some way not inside of us and can show us something, and then the moment when we see it, we get new ideas from this, or we make sense of it. Because of course the machines, they do not know what they're doing. They do not have intention by themselves. And then there's the question of the black box, because yes, we say, but we do not really understand what's going on there, which is actually, like, we are getting a much better idea now what's going on, but in some sense, not really understanding how a tool works has also never prevented us from experimenting with it and like starting with it and figuring out over time how it works. I mean, people who cracked together two rocks and suddenly sparks came out and made fire probably didn't know what kind of physics are going on there. Or if you do not have to know how to build a piano or how exactly the physics work in a piano in order to play beautifully with it or compose something on it. So in that sense, I also think, well, these new tools are a very promising way to kind of maybe open up some new roads to like show us something which hopefully brings us further. All this, what I'm talking about, is of course deep learning. I mean, media calls it AI. I really am not comfortable with that term, of course, because the press uses it and it's easy for everybody, because everybody thinks they know what they are talking about. But the problem is, once the real AI comes along, we will have to come up with a new term for it, because now we have totally kind of sucked all the flavor out of it. So anyway, I want to give you actually a little bit of a kind of a quick rundown. Because I just arrived, I don't know how much you have already heard during the day, but let me give you my take on how this working with neural networks works for me. So as you probably know, AI or deep learning was invented to turn cats into data, or to be precise, to figure out if on a digital image there's a cat or a dog. And in order to do that, well, the machine gets a lot of information already in the form of all these pixels that are contained in the image, but it's just too much information. So what it has to do is it has to reduce that information to a point where at some point it can say, oh yeah, there's a cat on this or a dog. And one tool that helps doing this is a so-called convolutional neural network, where, well, in the beginning, a pixel image is thrown in, and every step, the information is kind of on every layer, the information is reduced a little bit by these convolutional layers looking at certain features. And if you look in these kind of inside of a neural network, it's actually pixels all the way down. It looks almost like somebody's using Photoshop in a bad way. What is interesting though is, as the information from the top, when it's still an image, to the bottom is more and more condensed, the type of information that is being passed on gets from stuff that is more superficial, like textures, edges, and kind of decorative features, to information that is semantic, where in the end, like if you look, oh, nobody was laughing! Sorry. So these were some of the pictures I didn't show before. So just to reiterate, yes, this one. Okay, so now, let's not overload the thing. All right, this was, I don't know if you already saw this or if nobody just, I mean, that was unfair, just not saying anything. All right, okay, God. So this information, like the further it goes down, it becomes more and more semantic. So that something like what you see in the corner here, like this one little pixel dot might then resemble something like the concept of a face or an eye or really some element there. And so, in some sense, if you look at kind of the different phases in which that an image is classified, so you could say that the upper half is more dealing with style and decorative elements, and the lower part is then semantic content. And where it's then really getting interesting is just before the model is then able to tell like what category, like what is on that image, if it's a dog, a cat, or a house, or a car, it creates a so-called feature vector. And that feature vector is a multi-dimensional number. Typically, it's maybe 128 dimensions or 2000. But the interesting part about the feature vector is that every image that gets fed through this model, and it gets this unique coordinate in a multi-dimensional space. And while you train the model learns to kind of transform that space in a way that everything that belongs to the same category ideally ends up in the same area in that space. And so kind of every object has its unique coordinate in there, and objects that are similar to each other will also be kind of closer to each other. And because we cannot really, we cannot really think in like 128 dimensions, but you could also just imagine it in 3 dimensions, because so then after like classifying all these images, the cats might end up here, and the dogs might be here, and the cars might be there. And for the model, this makes it very easy to answer that question then, because if a new image comes in and ends up here, well, it has to say, okay, well, this is all kind of the cat area, so I'm pretty confident that what is on that image is a cat. Because we cannot really think in 128 dimensions how this space looks, and that space is called a latent space. And in a way, when you train a model, you build up, in a way, this new universe based on the training data you use and the questions you ask. But there are mathematical methods how to kind of how to break down, like how to project these 128 dimensions down onto 2 on the screen that we can see, and that looks like this then. So it almost looks like a country or a landscape. And what will happen then is that actually the cats will land up somewhere in Poland, but and the dogs might be somewhere else. But because this multidimensional folding is not as intuitive as you might think, some of the cats might also be in a different country. That might be kind of drawn cats, whilst the other ones are cats on photos, depending on how the model decides to split up kind of this space. And down here in, what is it, like in the Himalayas, there might be people in cat costumes. But the fascinating thing about this latent space is that now you have a mathematical way to compare images and like measure, like really in numbers, how similar 2 images are or how dissimilar they are. And that is already a powerful concept to kind of try to understand how machines see versus us, or like how to later on produce images. So one project that uses this concept of measuring the similarity of images is one that I made during my residency at Google Arts and Culture, and it's called X Degrees of Separation. Google Arts and Culture works with museums and collections and helps them digitize cultural artifacts. So in the end, the museums get all their like paintings, sculptures, photography digitized. They own the data, but Google also is able to collect this huge database of cultural artifacts where, for example, at the lab in Paris, we can experiment with this data and try to find new ways to make discoveries there, to access this huge amount of information, because that's the problem. Once you have access to 1 million of potential artworks, where do you start searching? What are you actually looking for? So X Degrees of Separation in that case is like one idea how you can make discoveries, and it's kind of loosely based on the concept of 6 degrees of separation, where in the idea that you are connected to every other human on the planet by a maximum of 6 acquaintances. So I know somebody who knows somebody else, and over a few steps you kind of make a connection to any other human. And here I ask the same question: can I find a visual connection between any 2 cultural artifacts or their images? And in particular, I wanted to ignore all the metadata and just focus on the visual images. And what I'm using is that feature vector that you sometimes inadvertently use when you drag an image onto Google Image Search, which then gives you similar images. And so I get these vectors from all cultural artifacts and start then connecting the nearest neighbors. So you can imagine I build streets, like some image has 10 neighbors and I build streets, but then they are connected to others. And then I can ask, how do I get from this painting to this Buddha sculpture? And like a car navigator, I can then, like it takes the shortest route to get there, but simply using these feature vectors. And of course, the results it gives us are totally different than a human curator, like decisions a human curator would make. But at the same time, I find them quite, in a way, they are compelling, because you definitely see these multidimensional gradients the machine does through color, texture, shape, and lots of other things that might not be even categorizable because we don't have words for something that is a mixture between, I don't know, texture and color and shape. And well, what I find interesting here is then that you can start this search through this huge amount of images by something you know and maybe end up with something else you know. But in between on that trip, you might find something that you haven't seen yet or is surprising and might interest you to explore it further. And of course, at the other hand, it also shows you, like, there are similarities how machines see images, but then there's also things where for the feature, like for the algorithm, the background, for example, is just as important as the foreground. So it has to fix all of these things at the same time, where we would make compromise, like we would say, okay, just look at the faces, for example, or the material. I'll have to go a bit quicker, I guess, because of the time I lost. So another way I use this concept of finding similarities is using movies, and there's a huge amount of public domain movies on the Internet Archive, mostly educational movies or kind of silent movies. And again, I can try to apply the same concept, only, well, trying to, like, first taking a feature vector of every frame in a movie and then trying to find scenes automatically this way, which actually works. So you give it the whole movie and it tries to find where are the cuts and then make a single feature vector for every scene. And then it allows me to query the whole database of all scenes I have. So what you see here is, on the top left is a scene that I query, and on the rest is then where the machine believes these scenes are in some way visually or semantically similar to the input. Among, I don't know, I think I have 200,000, 300,000 different scenes. So, and there are some interesting kind of associations and of course you could call it also misinterpretations that the machine makes in its choices. But at that point I find these choices, of course, very inspiring and creative in some sense, because you could say, like, oh yeah, now that you show this to me, I can definitely see that there is some similarity going on and some associations you might even make as a human when you, I don't know, see a centipede and people walking. So I took this concept further and asked the machine now, okay, I give you an entire video clip. In this case, it's Sabotage by the Beastie Boys. Cut that up into scenes and then replace every scene with another scene from the ones that you know. And let's have a quick look, and I hope the sound works. Yes. Show the entire thing. Unfortunately, you can't see the entire clip anymore because it was taken down. Of course, this happens all the time now when you steal, when you use other people's sound. But as you saw, there are sometimes really interesting juxtapositions happening where the machine, like really makes nice associations. But so, of course, this was all using just these like classification process where I take something and get these feature vectors. As a result. But now, of course, I want to reverse the process and say, I have feature vectors and make me images from this. Or I have this latent space and like, how does it look in there? And I call this technique neurography, or you could, like, short for neural photography, because that's kind of how I see it. So by training a model, you create a new latent space, which is in a way a universe in itself. And then I can go to coordinates in there or to places and look around, like have the model show me what happens there, and then, like a photographer, I can decide, oh, is this already kind of the scene I want to see, or do I want to turn around, move away, frame it differently? And so it almost works like this when you are in this space. And So one early technique, and I think we saw use of that technique also in some early examples, is so-called plug-and-play generative networks, which really tries to take kind of noise and then in this iterative process optimizes this noise until it resembles a certain category in this, like in the trained network, so it looks more like something that it knows. And but the interesting thing is that you can interrupt this process and say, okay, don't get too concrete while you fly through the space, but end up a little bit earlier when the images are still in this abstract, weird kind of, but yeah, aesthetic. And what happens is that you can see this space is continuous. So whilst flying through, this is not like jumping around, and shapes morph into each other. And at the same time, they might resemble you of something, might remind you of something that, I don't know if it's called, could be called abstract art or something a 5-year-old would have drawn, but there are these elements that look familiar to us because the model has also learned from the real world. And in that sense, it takes shapes and colors and things, so it doesn't create noise. And so this is already kind of an interesting way to produce abstract imagery. And of course, in the end, the machine doesn't know what it's doing, and in this process, it's still me who in the end has to go through thousands of images and pick the ones that I find maybe compelling. Also, of course, I might end up with a space which is not interesting at all, and where I have to go back and adjust the training data, the training process, to get something that I find more interesting in the end. But so this was a technique that was very early. I mean, I think it's like 2.5 years old or so. So over time, this field moves so fast, and of course, you have heard about this. This is what all of us are mostly using now, is the GAN, and I hope I don't have to explain the principle again. So that saves me 2 minutes, because you all have heard probably like how GANs work. One flavor I like to use a lot, because GANs come in different types of principles. There's the one that takes a feature vector and turns it to an image directly, so it's kind of a z-coordinate to an image. I prefer to use a technique called pix-to-pix initially, which is an image-to-image translation. And in some sense, so you give the model a sketch, a kind of very low information content image, which can come in very different forms, and then that it learns to transform that sketch into something that might resemble a photorealistic image or something that looks like a painting. But what it learns is this transformation. And I find using this principle very intuitive, because you have a lot of kind of places where you can influence the results. And of course, the idea is that you try to give the model as little information as possible, because that will force it then to add all the missing information by learning the training data well. So the first thing where I applied it to, because I'm pretty sure you know edges to cats, which is kind of looks like edges to handbags, where you take some simple sketch and it produces you then a cat-looking thing. I was more interested in trying to replicate this enhance effect from, like, you know, in the movies when they have a very blurry image of some criminal, and then they press a button, can you enhance that, and suddenly it's all sharp. And yeah, the idea is really you train a model with pairs of a real image and a very, very blurry one. And the model, over time, tries to learn to reconstruct how the original images might have looked like. And this is then an example what the model gives me. So the input is the blurry image on the left, and the output is this. And of course, it's not very sharp. But once I saw these artifacts, of course, it looks kind of painterly at first. But if you look closer, there are some really interesting new types of artifacts happening. So I stayed with this technique for a while, and called it, instead of enhancement, I call it now transenhancement, because in some sense, the model is really producing these new type of artifacts. And what is fascinating is that it allows me kind of to zoom in, like almost like in Blade Runner style, I can constantly look further how this what kind of detail might be in there, because all I have to do is blur it and reconstruct it. And then suddenly artifacts become new types of shapes, which might look like a cave or, I don't know, something I at that point hadn't seen yet. Well, what you can see here is clearly typical artifacts that now we start to associate with the typical aesthetic that neural networks produce. Some people call it GANism, and that is kind of based on that convolutional nature of these networks. And maybe this is kind of what will date this type of aesthetic in 10 years when we look back. Because as you will see, as you have probably seen in the previous talk, the technique's getting better and better. So these nice, interesting artifacts, we will have to force them at some point. Like right now, they are kind of a side effect and almost unavoidable, but this will be like the JPEG artifact. So this will be something we will associate with neural networks when we look back. So what I'm very interested in textures, and so I'm using these a lot to find kind of new types of textures, because as I learned, texture cannot really be seen independent from the rest of the image. And because these models produce images as well as the content in some sense, as well as the surface at the same time, they in some way organically grow together. And I guess that's what, for me, makes the fascination with how these models generate images. So one part of what I'm doing is I'm making my own training sets, of course. I'm trying to avoid kind of pre-trained models from other people, like obvious. So I'm looking around in the world and see kind of what images are there, or what kind of special themes interest me. So one thing is I love decay, and I found, for example, a beautiful data set of a public domain data set of old glass plate photography. So I try to have the model learn this photographic decay. So in the end, the model is learning to produce interesting faults in photos. Other things are machine parts, old engravings, plastic robot parts. But in the end, kind of, this is always just kind of depending on how you use it. Texture can become structure again, and the model reinterpreting its own outputs, brings me into spaces which at least sometimes are aesthetically interesting and allow for a lot of experimentation there. Here we have an a model trained on electron scanner, whatever, microscopy. And this is kind of an pumpkin emoji in 10,000 magnification, 10,000 times magnification. So, but as you can see, the model will add on details and produces something that is kind of surrealistic in some way, or realistic, or maybe it's new realistic, I don't know. But as you saw before, these models are very easily create stuff that looks abstract. But of course, when making art, there are typical themes that we appreciate, and one of them is the human pose. We all are interested, in seeing what other humans do. So having some human pose in an image already kind of asks us what's going on there, because we are human beings, and we are in a way social beings. So I tried to train a model on learning how to make human poses, and in order to do that, I have to first collect a data set of how humans are typically posed. So there is a neural network. There are neural networks that allow you to take a video or photos and extract, look for all the persons who are standing on it, and or somehow pose there, and it will return you a stick figure of them. So what you get is kind of a data set of 16 coordinates, and when you start collecting 100,000 of them, what you will get is a data set that kind of tells you how humans are typically possible to be posed. And that then allows me to first create new poses which are let's say, realistic, because I can interpolate between them, I can extrapolate from them, I can, and can create kind of new data from the existing one. And if I just interpolate through this space and add a little bit of rules like that there's a floor, what these figures will suddenly do is they might appear like they are dancing, right? But in the end, what's happening here is that the machine is just looping through certain different poses and creating the new ones in between. And now that I have this, let's say, universal pose generator where I can have a machine that can give me new ones, I can train a similar model like the one you've seen before, where I enter a sketch and get an image out on these kind of poses. In the end, first I have to train it on real poses and photography pairs, and after a while it learns these, and then I can enter random new poses and it will produce me something like this, which again is using the transenhancement technique, so it has this weird artifact painterly look, but in the end all my input I give it is a new random pose and I get many different outputs. So in this case my training data was actually pornography, because in pornography you get a lot of full body poses that you can then kind of like, I could have used sports, but that's kind of not so much of my interest. So, and then, you get, like, in the end, again, I have this system where I can continuously produce new poses and see what the model gives me, and I find some of those results quite interesting and different. And what you get, of course, a lot is this reminds me of this artist, and this, for example, reminds me a lot of some Dali painting. So, or this reminds probably 90% of all people of Francis Bacon. And this is what I get a lot. And of course it's a problem, but on the other hand, I think it's also a way how if we see something new, we love to kind of categorize it in some way. And if you take a face and mash it up, and it looks like a painting, then we do nearest neighbor search in what we know, and we associate it with Francis Bacon, because he has this huge gravity field there, where like he has this kind of position where he's very alone there. So it's very hard to escape the gravity. But on the other hand, if you put these things next to each other, then you will see it's not exactly the same. This piece actually won me the Lumen Prize this year, so it seems like other people find it interesting too. So I hope I kind of can start to escape the Francis Bacon gravity field at some point, but it is hard. Well, apart from poses, of course, what's more interesting even is the human face, and I work a lot with faces, and again, of course, I try to build various models that allow me to create new human faces and play with them. So again, the principle is the same, that at first have to make a training set, and I can use neural networks that give me back so-called biometric face markers, which are also used in surveillance. And again, in the same way, like that I give it a sketch, very low information, low dimensional information, and the results that I want to get in the end. Here, for example, it's some engravings from the British Library. I can then have the model create me new faces from what it knows. And this was an early example. You see the quality is still kind of rough and artifacty. And of course, one of those tasks that I'm trying to achieve is getting the quality better. So also the speed. So in this case, I managed now to get something like, almost like a real-time transformation of my face markers in this case. So it's actually not a filter, but it's just taking my markers of my face. And in that case, I trained a model on just photo models, actually female ones. And yeah, one thing you can see is because all the model has been trained on is to see faces, it will try to find faces in everything. Of course, in this case, well, it's even close to a face. I mean, it's not a human face. But of course, the other thing you see is all the interesting mistakes it makes, which is kind of what I'm more interested in getting realistic images out. For me, getting it realistic is more like a benchmark to see how good has my model become, but it's more like knowing the rules before you can break them. Another example, the same model, like the recognition model, actually it's two, that has been trained to recognize human faces, will also try to see faces in everything else. So this is not another model that has been trained particularly on sketches. So it is interesting to see like how far can you take the input data off what the model has done in order to get something new out of it, which is actually where it's getting interesting, kind of this breaking the models or trying to break them in interesting ways. So, of course, training data, we heard that before, is always biased. And in this case, I call this my old master's GAN. So I took Western European portraits, like from art history, and trained a model that is able to make me new faces from them. And these are generated ones, but you can already see the problem that it's all kind of white middle-aged men and a little bit younger white women mostly. So that is, of course, the question, like, do we need more of those? The problem is, I mean, the aesthetics are quite, like, well, people like the colors and the textures. So I have a hard time, and of course now if I want to de-bias that data set, it is very hard to find kind of a lot of counterexamples of non-white people. So this is then, of course, a task I have to do. But of course, I'm not using these models to create kind of portraits of this kind. I'm more interested, there's a yes, for example, to kind of abuse these things in other ways. And again, this model that is seeing faces and everything, so you can always try to see like how far can you take this. Titanic. Yeah, we have to wait because, yeah, this is important. What I kind of do usually, like how I usually work is I build feedback loops. So I take one model and often another one. Sometimes they are reciprocal. So in this case, I have one model that creates faces from markers and the other model makes markers from faces. And what I can do then, of course, is I feed the output of the first model into the second, and then I feed back the second model into the input of the first. And then interesting things are happening because both models in this process misinterpret the output and make mistakes because they're never perfect. But of course, exactly in these mistakes, interesting accidents happen that are, well, much more, for me, visually much more interesting than just making regular faces. So yeah, I've used this technique in various installations. So this was something recently at Ars Electronica, again, where now I'm also trying to get the resolution up, get more detail, because again, I think texture is, so I don't think AI art is about creating low resolution, kind of crummy pictures. This is kind of like we are beyond that, and texture is an important element of images that we can appreciate them. So this is a field that I'm trying to work on and let's say actively research because it's actually difficult. This is kind of a piece, actually my first collectible AI in a box, you could say. So what it is, because that's the other thing. The question is the single art, like I have now these systems which are able to produce infinite amounts of different looking outputs, which of course at some point might not be that different anymore. But is that really about producing a single artifact anymore? Or isn't it more about kind of the idea of that system which is able to create within a certain confines for eternity? So what I'm doing is now I'm taking the systems which contain the models and everything and try to get them to a state where I can rely on them that they will not kind of die. Because that's like when you have feedback loops, of course there's always the danger that at some point it might just go all black or all white or nothing happens or it freezes up. But then I have this system and put it in a computer, and this is then my art, which I sell. So in this case, it's called Memories of Passersby, and it will produce kind of this endless flow of metamorphosing portraits, and sometimes some are more beautiful, some are repulsive, some are really boring. And I think the interesting part is actually that if you see something that is beautiful, you will only be able to see that in this moment. It will never come back. And it's also like the longer you watch it, you realize that even more. That in this time when we could do infinite undos and screenshots and everything, you can make something that is just a fleeting moment. So there might be a potential with these neural networks, which is also then kind of, again, the question, okay. I think that still I am the artist in this case. I'm just building an almost living system, but I still have to kind of direct where it's going. I was talking about the feedback loops. So there are interesting things because the feedback loops also becoming for me like these seeds for new content, for new kind of this structure that underlies images. So here, for example, is a model that misinterprets some post-generating model, and what you get is something like almost like a sculpture that is in constant metamorphosis. I would love to build this in some way, but right now I can only watch it on, of course, as a video. Or here is a feedback loop of my hair, face, and eye model. And again, like, I only can set the system in motion, but then the intermediate images that come out, I can kind of take snapshots and feed them into other models. So I build these pipelines where one model takes the content of the first and processes it, passes it on to the next. And of course, in this feedback loop, it becomes interesting to say, okay, what have I still done there? So, and of course, I find these results quite surrealistic in some sense, and of course, the model again has no intentions, and we start seeing familiar elements, and again, then they don't make sense. So, but yeah, they create some kind of a new aesthetic, which at least I have not seen that way, which makes it for me right now quite, I'm achieving what I was hoping for to get, that the machine is really showing me these new visual worlds. Here's another flash formation. Oh, the last thing which I'm currently doing, and then I'm done, is called Neural Glitch. And the idea is, if I have a trained model, which at some point is, you could say, finished, right? The training is done, and then you use it for generating, you can still manipulate kind of what it has learned. So here we have an example where the top left image is kind of the default what the model generates, a typical portrait. But then on every step, I delete half of what the model knows. I kind of zero out the weights that it has learned. And the interesting part is that even though, like in every step, it has forgotten half of the things it has learned, it still is able to produce something like a face or the resemblance of where we might still be able to recognize a face. And it reminds me a lot of these artists that develop Alzheimer's disease at some point, and where their capabilities start kind of decreasing, and it goes from the concrete, the details get lost. And so in some sense it's interesting how these models are also, by adding these glitches, you learn a little bit more about how these models make images by kind of taking something away from them. So I experiment a lot now with kind of taking the same input, glitching the model, and because the way these models are made, that they have a semantic part and a more kind of superficial part, the glitches that you introduce, like where you kind of randomly change values, can sometimes be just on the texture level, but sometimes they can also change the expression of a person, or the direction where eyes are looking, or the eye color. So these are, in a way, semantic glitches, and I find this space currently very interesting to explore. And of course I'm using again my white female model, but there's also, because yeah, it's again also like a benchmark for me to test. Well, this is I think me, then if I glitch myself, I can also, like, it's the same input data, but different glitches. So you get kind of a very different aesthetic. And this is actually also the same input data, and where the semantics are more kind of mixed up. And so you see, even with a fully trained model, you have still a whole variety of places it can go. And so, sorry for all the technical difficulties. Damn it, yeah. So next time I bring my slides. Thank you.